plotting an LAN Running Fix for the U.S. Coast Guard sample exam, or the U.S. Coast Guard Oceans exam, using the same problem we set up the plotting sheet for. The sunline is already worked out. I'm supposed to say 10, not 45. I'm an idiot. Sunline is already worked out. Latitude at LAN is already worked out. The 910 sunline gave an assumed position of 23 north, 156 degrees, 58.9 minutes west, an azimuth of 4.7 away, an intercept of 4.7 away, and an azimuth of 118.5 degrees true. The calculation of latitude at LAN was 22 degrees, 28.6 minutes north. What we have to do is take this line, plot it, and advance it to that line. The first thing we have to do is plot the assumed position of the 910 line. Here's 23 degrees north. Go over here to your longitude scale, measure out 58.9, bring it over to 156, make a mark. There's your AP. Now plot the azimuth, 118.5, as best you can, 118.5. 118 goes in that direction. The intercept is away, so it's going away from the sun, so I'm going to make a dashed line to designate the away direction. Take my dividers, measure out 4.7 as best I can. Make a mark. Boom. Okay. I made a mark on my line, which is right there. Okay. Now I'm going to take my triangle, make sure it's lined up 118.5. Just double check. Now I'm going to flip the triangle like that, which gives me a 90 degree, exactly 90 degrees to the bearing line that I plotted. Find my mark, lay down my line. That is a 0, 9, 10 sunline. Okay, now I'm going to advance this line down my track line to LAN. So I'm going to take this position, the distance traveled between 9:10 and 12:45, which is marked on my plotting sheet by the DRs. I'm going to pick up that distance spread, show it where my 9:10 line crosses my track line. Then I'm going to make a mark down the track line for my advancement. Now, that distance that I advanced it is the same distance that's between 9:10 and 12:45. You can do this either by measuring the distance by DRs like a navigator would do, or you can take out your calculator like a math student and do a distance equals speed times time. Now, once I have that done, there's two ways we can do this. Take the working line of your triangle, line it up on your LOP, and slide it down to the mark and plot your line. Just like that, okay? Hairline on your line of position, slide it down your track line to the mark that you made with your divider, and then lay down your advanced LOP. Okay, that's one way. Another way is noticing where that mark is, take your triangle and measure out on the latitude line 118.5 degrees. Slide it over to your mark. Probably better to do it this way. You got more to work with. 118.5 is right there. Slide it over to your mark and lay down your position. This works because this line, the meridian and the latitude line, are 90 degrees from one another. I measured the azimuth off the meridian. Therefore, my LOP, if measured off the latitude line, will give me a 90-degree position, a 90-degree angle towards that azimuth. This is labeled 0910 to 1245. Okay, and the next thing you do is you just lay down your latitude of 28.6. So I take my divider, line it up on the meridian, find 28.6, lay down a position, and it's 1245. Lower limit of the sun, circle it, label it. Okay, that is the position, and the question asks for longitude. So I measure the distance from a meridian to the position. I'm measuring it from the 157 line, so I don't have to do any mathematicians there. Okay, put it over on the longitude scale. All right, 40 something minutes. So I see that it's 40, shift it over to 40. So it's 44 minutes and some change. So we're looking at a longitude of 157.44 west. And that's how you do a sun plot, just LAN.